Hello, and a warm welcome. This video provides practical tips on the commissioning of the WIWA DUOMIX 333 PFP. Specifically, this means what you need to do to set up this system and carry out coating operations with it. The WIWA DUOMIX 333 PFP is a dual component coating system for applying insulation layer forming flame retardants in commercial and industrial applications. The WIWA DUOMIX 333 PFP is used for coating steel parts in structural engineering as well as in the oil and gas industry. The instructions, tips, and information provided in this video are based on the operating manual and the safety notes for this system. It is good practice to read the instructions in advance, which will help you better understand the guidelines provided in this video. Also consider that only WIWA service staff or trained personnel are allowed to carry out maintenance and repair work on the WIWA DUOMIX 333 PFP. Let's begin, and that with the next safety note. Do not start commissioning the system unless you have the specified protective equipment. For details on this topic, refer to the corresponding operating manual. Let's now consider the material that you want to process. Always observe the manufacturer's technical information on this topic. You will need an adequate amount of material and 2 containers for collecting excess material. These containers are not included in the scope of delivery. You must ensure that the system is installed level and on a solid surface to prevent it from tipping or tilting. All controls should be easily accessible. Make sure that the proper power supply and compressor with a capacity of 5,000 liters per minute at 8 bar or 150 CFM at 116 psi required for the operation of the system are available at the installation site. You can use either a compressed air supply hose with a diameter of 1 inch or 2 with 3/4 inch diameter. Please observe the maximum permissible pressure for the compressed air hoses used. Here's an overview of the first important points again. 1. Please read the operating manual. 2. Maintenance and repairs must only be carried out by qualified and trained personnel. 3. Only work with the specified protective equipment. 4. Follow the safety notes provided in the operating manual. 5. Observe the technical notes of the respective material manufacturer. 6. The unit must be installed in a level position. 7. An adequate main supply and compressor capacity must be available. In the next step, I'll point out the individual system components. Control box. Control unit for main pump, flush pump, and pressure tanks. Contact pressure gauge of the pressure and dosing control. Adapter to connect the hose package. Fluid heaters and pressure gauges. Agitators. Control unit for feed pumps. Flush pump. Pressure tank for B component. Water circulation reservoir. Feed pump for A component. Feed pump for B component. Ram for B component. Ram for A component. Ram control. Cleaning agent tank. Air maintenance unit. Pressure tank for A component. Water circulation pump. Main proportioner pump. The frame is equipped as standard with wheels, forklifting pockets, and 2 crane lifting eyes. This allows for easy transport and installation of the unit. I'll explain the system control components first. I'll start with the control box, which contains all control elements such as start-stop buttons, the selector switch for manual or automatic operation of the pressure and dosing control, and the timer to set the operating time for automatic operation of the water heating and circulation pump. The 3 position on-off switches of the circulation pump, water heater, and agitators are located next to the error message signal lamp on the left. In position auto, the corresponding system section is automatically switched on and off in accordance with the operating times set with the timer. In position 0, the corresponding system component is switched off. In position manual, the corresponding system component is switched on. On the far left, you can see the on-off switch for the material flow heaters. Particularly important, here you will find the master switch to switch the electric system on and off. The contact pressure gauge of pressure and dosing control is mounted below the control box. The contact pressure gauge monitors the pressure of the B component, the hardener, and switches the system off when the operation tolerance is reached. It is connected to the control box. You can use the stop button to manually shut down the system. The start button is used to restart the system after a shutdown. The selector switch is used to activate monitoring of the operation limits in the pressure range. For startup, the switch is set to manual to monitor only the upper operating pressure. For spray operation, set the switch to automatic, as both limits should be monitored. The control unit of the main pump, the flush pump, and the pressure tanks is located here, next to the control panel. The operating principle of all the compressed air regulators installed on the system is the same. Turn to the left or to the right to reduce or increase the pressure respectively. Here you will find the water circulation temperature indicator and the A and B component temperature indicators with scales for both Fahrenheit and Celsius readings. The RAM control unit is located in the center of the RAM system. Here you will find the air pressure regulators and the control levers for the A and B component RAMs and the pressure gauges used to indicate the operating pressure of the system components. The control levers are used to move the RAMs up and down when changing the material containers. Here at the top, you will find the A and B component feed pump control unit, the shutoff valves, and the pressure gauges that indicate the operating pressure of the A and B component feed pumps. The 2 shutoff valves are controlled by the level monitoring in the pressure tanks. Once the minimum material quantity is reached in one of the pressure tanks, the shutoff valve of the component is opened automatically. The corresponding feed pump then delivers material into the pressure tank until the maximum level is reached. The shutoff valve is then automatically closed and the feed pump is switched off. Now I would like to explain the fluid handling components. First, I will show you the flow diagram for the material in the system. The 2 rams here assist the feed pumps in transferring the material to be processed. You can place the material drums here once you have run up the rams. The feed pumps deliver the material from the drums into the pressure tanks. The double-walled pressure tanks with the agitators are located here. Circulation water flows through the area between the outer and the inner container. The material is stored and heated in the inner container. Hint: a temperature controller is installed at the inlet of the hot water circulation on the A component pressure tank, which can be used to adjust the temperature of the circulation water in the 2 pressure tanks. Always observe the operating instructions for the temperature controller. The agitators mounted on the pressure tanks provide for uniform heating and consistency of the material by drawing it from the wall into the middle of the container, rather than stirring it up from the bottom. You can turn on the agitators at the control box. The material to be processed is transported by the main pump from the pressure tanks through the material flow heater to the hose package, the mixing unit, and the spray gun. The air motor drives 3 material pumps, 2 for component A and 1 for component B. The mixing ratio results from the ratio of the pump sizes. Depending on the material requirements, the mixing ratio can be adjusted by exchanging material pumps. The only thing you need is the proper tools and the appropriate pumps. 3 material flow heaters are located in the lower section of the system. They can be switched on and off at the control box. The temperature regulators are located directly on the heaters. From here, the material is transferred to the adapter for the hose package. There are 5 levers on the adapter, used to open and close the material outlets to the hose package, the return flow to the pressure tanks, for example for circulation, and the feed and return flow of the hose heating water. The hose package is mounted here and heats the material as it is transferred to the mixing unit and gun. The mixing unit has 4 levers used to select the stop, spray, flush, and volume control operating modes as follows. For the stop mode, set the volume control lever and the large spray lever to off. Set the 2 small flush levers to off. For the volume control operating mode, the volume control lever must be set to on, the spray lever set to off, and the flush lever also set to off. To switch to the spray mode, set the volume control lever to off, the spray lever to on, and the 2 flush levers to off. For the flush mode, set the volume control and spray levers to off. Set the 2 small flush levers to on. A very important component is the flushing unit, which is used to clean the components which come into contact with mixed material before the pot life is exceeded. The flushing unit consists of a flush pump and cleaning agent reservoir, drain valve, heater, and temperature controller. The cleaning agent reservoir can be connected directly to a cleaning agent supply system, not included. In this case, a float automatically regulates the cleaning agent supply. The unit is designed for flushing with water. For flushing with solvent, you need the appropriate mounting kit. This is the circulation water reservoir, which is used to store and heat circulation water. The temperature regulators are located at the back of the reservoirs. The temperatures of the cleaning agent and circulation water are adjustable and can be read on the control unit for the main pump, flush pump, and pressure tanks. The heater elements are turned on and off with the water circulation switch on the control box. Important: to maintain an adequate supply of heated water for flushing, it is recommended that the water circulation remains on during system operation. The circulation pump provides for recirculation of the heating water. Finally, we come to the air maintenance unit. The maintenance unit prevents condensed water and dirt particles from entering the motor and supplies oil to the compressed air for lubrication of moving parts. The de-icing system adjusting screw is also located here. So now you have a first impression of the WIWA DUOMIX 333 PFP, and we can take a look at commissioning of this system. Secure the system at its final location. For this purpose, use the wheel chocks which are clipped onto the unit frame. After transporting the unit, position the yoke vertically and secure it with the locking pin to avoid the danger of stumbling and injury. Before proceeding to the installation, check the maximum permissible pressure for the spray hose, spray gun, and all accessories. These must be higher than or equal to the maximum operating pressure of the system as specified on the machine type plate. Compare the maximum operating pressure of the safety valve with the specifications in the machine card or on the type plate. The data must match. The hose package, the mixing unit, the spray hose, and the spray gun were packed separately for transportation. I'll show you how to assemble these parts before the first use of the system. To mount the hose package, take a position in front of the yoke. First, connect the hose for the A component at the far left of the adapter. Then connect the hose for the B component to the second line from the left. Then attach the return hose of the hose heating, the feed hose of the hose heating, and the flush hose on the far right. Next, connect the hose package to the mixing unit. Make sure you connect the A and B components and the flushing hose in the proper positions. Connect the spray gun to the spray hose. Connect the spray hose on the outlet side of the mixing unit. The advantage of this system is that the ready mix material is only present in this section of the material lines. The system is now fully assembled. Now I will show you how to connect the air supply, the electric power supply, and open the venting screw on the contact pressure gauge. The maximum air consumption is 5,000 liters per minute or 150 CFM. To ensure an adequate air supply, the compressor capacity must match the air requirements of the unit, and the diameters of the air supply hoses must match the inlet connections. Make sure that the compressed air shutoff valves are closed and all air pressure regulators have been set to 0. Connect the compressed air line to the air maintenance unit. Electrical connection. 1. Check that the factory set electric power supply is enabled. 2. Make sure that the main switch on the control cabinet is in the off position. 3. Connect the power cable in accordance with the wiring diagram inside the control cabinet of the PFP system. 4. Check the rotational direction of the agitators. If the cable is connected correctly, the rotation will match the direction of the arrow on the agitator housing. Now that you have completed the above steps, the venting screw on the contact pressure gauge must be opened with a screwdriver before starting up the system. Detailed instructions can be found on the label of the contact pressure gauge. The preparations for commissioning have now been completed, and I can show you how to put the system into operation. We will start the system now, but first, please make sure that all compressed air shutoff valves have been closed. All air pressure regulators have been set to 0. The control levers of both rams are in the stop position. The spray gun lock is engaged. Open the compressed air shutoff valve on the air maintenance unit. Turn the main switch on the control cabinet to on, set the manual automatic switch to manual, and press the start button. Now we're going to put the flushing unit into operation. During work, the flush pump should always be ready for use so that all components which come in contact with mixed material can be flushed within the specified pot life. Connect the cleaning agent supply line to the cleaning agent tank and fill with cleaning agent. Here, water is used. The unit is designed for flushing with water. For flushing with solvent, you need the appropriate mounting kit. Turn the heater element on with the water circulation switch on the control box. If you use only water as a cleaning agent, Set the desired temperature on the heater of the cleaning agent tank. Important: if a cleaning agent other than water is used, ensure that the temperature controller is adjusted to 0. Now, I'll show you how to flush the mixing unit and the spray gun. Remove the nozzle from the spray gun. Select the operating mode flushing on the mixing unit. Hold the spray gun into an empty container. Unlock the spray gun and operate it until uncontaminated cleaning agent runs out. Depending on the length of the hose package, set a pressure of 3 to 6 bar on the pressure regulator of the flush pump. Close and lock the spray gun. Select the operating mode stop on the mixing unit. The next step, we have to clean the system. After assembly, this unit was factory tested for flawless function by means of a test substance. During initial startup, you must therefore perform a complete cleaning in order to flush out any test medium residues. Before we start cleaning the system, please make sure that the compressed air shutoff valves of both feed pumps are closed. Both ram control levers are in position down. Set a pressure of 1.5 to 2 bar on the air pressure regulators of both rams. Set the control lever of the B component ram to position up to drive the feed pump up using the ram. Once there is sufficient space for the material drum under the follow plate, set the ram control lever to stop. Place a container with flushing agent on the centering plate under the feed pump. Set the ram control lever to position down to move it down again. Open the compressed air shutoff valve on the B component feed pump. Adjust the air regulator for the B component feed pump to a low pressure. To clean the unit, please fill each component with approximately 30 liters of cleaning agent. After filling, close the air supply valve for the feed pump. The parts of the system which came in contact with the A component need to be cleaned as well. Please repeat the steps for the ram press and feed pump of the B component, for the ram press and feed pump of the A component also. Open the shutoff valves on both main pump material inlets. Open the return flow valves on the hose package adapter. Adjust a pressure of 1 to 1.5 bar on the air pressure regulator of the main pump. Let the cleaning agent circulate through the system for about 1 minute. Close the return flow valves on the adapter and open the material outlet valves. Select the spray operating mode on the mixer. Hold the spray gun into an empty container. Unlock the spray gun and operate it until uncontaminated cleaning agent runs out. Close and lock the spray gun. The main pump will stop. Select the operating mode stop on the mixing unit. Place the volumetric measurement outlets of the mixing unit into separate empty containers. Select the operating mode volume control on the mixing unit. Let the system run until no more cleaning agent comes out. Set the compressed air pressure regulator on the main pump to 0. Set the mixing unit to the stop mode. Open the air supply ball valve for the follow plate. Set the control lever of the B component ram to position up to drive the feed pump up using the ram. Once the sealing lip of the follow plate reaches the top of the container, quickly close the air supply ball valve for the follow plate. Once there is sufficient space, set the ram control lever to position stop. Remove the cleaning agent container. Remove the other cleaning agent container in the same manner. When the system is fully cleaned, you can fill the pressure tanks with the material to be processed. Make sure that the components are assigned correctly. Both components must only come into contact with the system components intended for this purpose. Standard component A is blue, hardener B is red. Place the container with the hardener on the centering plate under the B component feed pump. Open the ventilation ball valve on the follow plate and set the ram control lever to position down to move it down again. Once all air has escaped from the material drum, close the ventilation ball valve on the follow plate. Switch on the agitators at the control box. Open the compressed air shutoff valve on the B component feed pump. The steps shown for the ram press and feed pump of the B component need to be done accordingly for the ram press and feed pump of the A component. As a result, material will be pumped into the pressure tanks until the level monitors of the pressure tanks switch the feed pumps off automatically. To fill up the pressure tank completely with material, several drums of the A component and the B component are needed. To do this, the procedure just shown needs to be repeated several times. Once the materials to be processed have been filled into the pressure tanks, you can put the water circulation system into operation. Fill a mixture of 3 parts water and 1 part antifreeze to 10 centimeters below the top of the water heating reservoir. Switch on the water heating and circulation pump at the control box. Both water heaters will be switched on simultaneously. Open both ball valves for the hose heating at the hose package adapter. Set the desired temperature on the water circulation heater on the reservoir. Now I'll show you how to bleed the system. Open the return flow and close the material outlets on the hose package adapter. Use a 27 mm open-end wrench to disconnect the return hose from the pressure tank of the B component, and a 24 mm open-end wrench to prevent loosening of the nipple. Hold the return hose for the B component in a collection container. Use a 27 mm open-end wrench to disconnect the return hose from the pressure tank of the A component, and a 24 mm open-end wrench to prevent loosening of the nipple. Hold the return hose for the A component in a second collection container. Set a pressure of 1 to 2 bar on the air pressure regulator of the main pump. The pump should run slowly. Once clean material comes out of the return flow hoses for both components, close the return flow on the adapter. Use a 27 mm open-end wrench to connect the return hose to the pressure tank of the B component. Use a 24 mm open-end wrench on the nipple to counter-tighten it. Use a 27 mm open-end wrench to connect the return hose to the pressure tank of the A component. Use a 24 mm open-end wrench on the nipple to counter-tighten it. Now we can proceed to the adjustment of the de-icing system. Turn the de-icing system adjusting screw on the air outlet of the air maintenance unit for the main pump slowly counterclockwise, a minimum of 1 and maximum of 3 turns. Exact settings should be made individually and as required. Since the degree of icing depends on various factors such as pressure, pump speed, air humidity, and ambient temperature. When interrupting work, or in case of decommissioning, the adjusting screw of the de-icing system should remain open. Now we are going to put the material flow heaters into operation. Switch on the material flow heaters at the control box. Set the desired material temperature on the temperature regulators of the material flow heaters. Close the pressure relief valves on both pressure tanks. Open the shutoff valves on the compressed air connections of both pressure tanks. Set the desired air pressure on the regulators of the two pressure tanks to a maximum of 6 bar or 87 psi. Open the return flow valves on the hose package adapter. Allow the material to circulate until the processing temperature has been reached. The temperature of both components, as well as the temperature of the water circulation system, should be approximately 50 degrees centigrade or 122 degrees Fahrenheit. Now you will learn how to fill the hose package. Close the return flow valves on the adapter and open the material outlets to the hose package. Hold the volumetric measurement outlets of the mixing unit into separate empty containers. Select the operating mode volume control on the mixing unit. The hose package slowly fills up with material. The air inlet pressure on the main pump may need to be increased slightly to overcome the resistance in the hose package. Once clean material exits the volumetric measurement outlets on the mixing unit, set the mixing unit to the stop mode. Now we'll perform a volumetric measurement of the system. With the volumetric measurement, you can check the actual mixing ratio of the components. Always perform a volumetric measurement before starting work. Place clean, weighed containers onto the volumetric measurement outlets of the mixing unit. On the mixing unit, select the operating mode volumetric measurement. Fill the container with a certain amount of material. Select the stop mode on the mixing unit. Use the filled quantities to calculate the actual mixing ratio and check whether this complies with the nominal value. If the actual mixing ratio differs from the nominal value, check the material temperatures of both components, check the pressure in the pressure tanks for both components, and check the mixing ratio again. It is possible to slightly adjust the mixing ratio by changing the settings for the temperature and/or the pressure on the pressure tanks of the components. We recommend to preheat the mixing block, spray hose, and spray gun by flushing with hot water. Select the flush operating mode at the mixing block, unlock and trigger the spray gun. Heat up the system until you reach the appropriate temperature and switch the flushing ball valves to stop. The system is now ready for operation and you can start the coding work. Prior to coding, a system startup must always be performed. Select the spray operating mode on the mixer. Unlock the spray gun and operate it until clean processing material starts to run out. Close and lock the spray gun. Screw the nozzle back onto the spray gun. Adjust the optimal spraying pressure using the air pressure regulator on the main pump. Please observe the following instructions when adjusting the spraying pressure. Optimal spraying pressure is indicated by a uniform application of material with feathered peripheral zones. Operate the unit with an air pressure only as high as necessary to achieve a good atomization at the recommended spraying distance of approximately 30 to 40 centimeters or 12 to 16 inches. Excessive spraying pressure causes increased material consumption and paint fogging. Insufficient spraying pressure results in the appearance of stripes and a varying coating thickness. Set the operation limits for the current work process on the contact pressure gauge of the pressure and dosing control. The black pointer in the contact pressure gauge shows the actual pressure. Once you have set the optimal spraying pressure, You use the two red pointers to set the operation limits for the current work process as follows. Insert the attached key into the contact pressure gauge. Use the driver needle to turn the upper red slave pointer to a value of approximately 20 bar or 300 psi above the maximum pressure that is indicated when the spray gun is closed. Use the driver needle to turn the lower red slave pointer to a value of approximately 20 bar or 300 psi below the minimum pressure that is indicated when the spray gun is opened. Pull the key back out. Switch the pressure and dosing control to the automatic position. The pressure and dosing control must be readjusted each time the spraying pressure has been changed. If the pointer of the contact pressure gauge does not move, or moves only insignificantly, the system must not be put into operation due to the danger of mixing faults. To properly clean the system components which came in contact with mixed material, please proceed as follows. Set the pressure at the regulator of the main pump to 0. Press the trigger of the gun until the pressure at the gauge drops below 150 bar. Set the mode spray at the mixer to stop. Dismantle the tip. Select the flush operating mode of the mixer and trigger the spray gun. Alternately close and open both valves for flushing at least 5 times to clean the mixing block properly. Now open both valves for flushing at the mixer and let hot cleaning agent run until only clear cleaning agent comes out. Close both valves, put the tip back in the gun, and briefly flush to clean it. Lock the spray gun and close the valves for flushing again. Finally, a few important tips on coating. Hold the spray gun at a right angle, 90 degrees, to the spraying area. If the spray gun is held at a different angle, the coating becomes irregular and blotchy. Ensure an even speed and move the spray gun parallel to the area to be coated. Waving the spray gun causes irregular coating. Move the spray gun with your arm and not with your wrist. Begin moving the spray gun before pulling the trigger. This way you will achieve perfect, soft, and smooth overlapping of the spray jet and excessively thick application of material at the beginning of the spraying process is avoided. Release the trigger before stopping the movement. Replace the spray nozzle before it is worn. Worn nozzles cause higher paint consumption and have a negative effect on the quality of the paint finish. The DUOMIX 333 PFP can be installed inside as well as outside spray booths. However, outdoor installation is preferred in order to avoid damage to the unit by overspray. Protect the objects adjacent to the sprayed object against possible contamination caused by material fogging. As the owner, if the system is to be installed outdoors, you are required to take the appropriate lightning protection measures. This is a great deal of information to take in, but it will make it an awful lot easier for you to carry out your daily work on the WIWA DUOMIX 333 PFP system. For further information, please contact our headquarters in Lanao or our partners and affiliates in the USA and China. We will show you their addresses at the end of this video. We wish you every success.